Welcome to Microcontroller and Embedded Systems Laboratory. Today I will be showing you the demo for the experiment 5 in the part B. That experiment is called digital to analog conversion. So first let us look at the problem statement. Interface a DAC and generate triangular and square waveform. So actually, the DAC is the internal device in the microcontroller, and it can take 10-bit data. So we can replace n by 10 and feed the data. It will convert and give you analog signal, which can be displayed on CRO. And the waveform that we need to generate, there are two waveforms. One is the triangular waveform. It should look something like this. The square waveform should look something like this. So that is about the problem statement. Now I'll erase the drawings and go on to ports. There is only one port, P025 on the controller, which gives out analog signal. And this port is configured for analog output function. Therefore, we don't have to do anything for IO0 direction, but we need to program the pin select register with the value 10, binary value. And of course, we have to initialize pin select 1 because the port number exceeds 16 ports. And we define one constant A out having this value placed into pin select 1 register. So that is the initialization. So clear the drawings, move on to the next section. Okay, so we have programmed the ports, only one port actually, and now we move on to programming the register on the device. The device in this case is digital to analog conversion device, or a DAC it is called, and there is one register we need to program where we feed the value into the register, which is a 10-bit wide. Actually it's a 10-bit DAC. So you put a digital value over there, and the DAC device will convert this digital value into equivalent analog signal, which we can tap and produce on the CRO. So this is one programming that we have to do, and we have to set the settling time to 2.5 microseconds by setting the bit 16-bit one in the DACR register. So in this experiment, we have to configure one port on the microcontroller and one register on the DAC. So having seen the port and DAC programming, let us see how the DAC works. To generate triangle waveform and square waveform. So we have to feed the data into the DACR register between 0 to 1023, because 10-bit maximum value that you can feed is 1023. 10-bit is maximum value is 1023. So 0 means you are at the no voltage, and the digital value maximum is you reach a maximum voltage. Actually, microcontroller works maximum of 3.3 volts. starts, minimum is 0, maximum is 3.3 volts. So if we gradually increase the digital value from 0 to 10 to 23, we actually get output as a triangular way. And then once you reach 3.3 volts, you gradually decrease from 1023 back to 0. Then your output also drops to 0. So this is how you get the triangle wave. And to generate the square wave, what you have to do is you add the 1023 into the DAC register. You get the output 3.3 volts, and then persist 1023 for some time, and then remove the 1023 and replace the value in DAC register as 0, so that the voltage drops to 0, and continue in 0 with the same amount of time as when it is high, so that you get a square wave. And the output of the experiment, you can take it from the pin. There is a TP5 pin on the board, and connect it to the CRO. So we will show this diagram at the end. So the results that what you should get is when the program is compiled, loaded onto the microcontroller, you will see a experiment named DAC on the LCD panel, and connect the CRO from the TP5 pin, and the other probe for the CRO is connected to the ground. I will show it on the microcontroller board at the end. And the CRO, you set it to channel voltage as 1 volt, because the maximum you get is only 3.3 volts, so that you can see some y-axis content. If you take the granularity of CRO voltage y-axis as 1 volt, and the time period you take as 10 millisecond to see the clear waveform. And of course, you should be able to see the triangle wave and square wave intermittently. So let us clear all these diagram drawings, and then move on to the actual program. So as usual, we have the two include statements, one for LPC 2148. I'll bring it down a little bit. Okay. LPC 214x.h and mc.h. This is the A out is analog out function. The port number 25 we have to configure as an analog output, and the bias bit is 1, and the data is a 10-bit data. The 10-bit data starts from the bit position 6 in the DAC register, and we have to extract from the data register 10-bit data. So we have a mask here to extract 10 bits. So data is extracted from the DAC register by using this macro. Then look at the program. We'll go to main. Main, as usual, we have an infinite loop. So we generate 5 triangle waveforms and 5 square waveforms alternatively, and it goes on forever. And of course, there will be a small delay between triangle and square waves. So let us see how the triangle and the square wave is generated in the program. I will clear the drawings. Okay, go there. So first we will see the triangle. So this is the function called from the main. What we are doing here is we generate data between 0 to 1023 and put the data D into DSCR register starting from the bit position 6 to other position that is 10 bits data. And data is incremented to the next value, that is 0, 1, 2, 3 until 1023. So this should generate the rising voltage, and there is an immediate following loop where you start decrementing the data value from 1023 all the way to 0, so that you generate voltage which is decreasing. So these two loops will generate one wave, and if you repeat it for some number of times, you get waveform repeated for some time. So then similarly we can generate the square waveform. So the logic is same. Here we first put the data 1023 into the DAC register, 10 bit data actually, starting from the bit position 6, and so the voltage rises to the maximum, which is 3.3 volts, then persist for 1 millisecond, and then suddenly drop the data to 0, so that the voltage becomes 0 again. So repeat this for 5 times. So you get a square form. So that is the logic of DAC experiment. Now let us see the connections on the microcontroller board. So this is the microcontroller. DAC is actually inside the MUP or core. DAC is inside. It's an internal device. And the port number 25 is also part of the microcontroller. So assuming that we get the analog output from the port number 25, which we take it out from not this one here. This is the TP5 connector, not this one. So this one, analog output comes here, and the CRO probe 1 is connected here, that is red probe, red lead, and the other connection is connected to the ground. This is the ground. So you connect to CRO, probe is connected to CRO. On the CRO, you see the square and the triangle wave. So it's a very simple experiment because DAC is inside the controller. So I guess we will just like other programs, we will see what is the effort required from your side to remember this program. So you need to remember that you have to program the port which is 25 with the function A_out. A_out is actually what is the value of A_out? 10, binary 10 or hexadecimal 2. This value is put into 2 bits in the pin cell register. Since the port number 25 is beyond 16 port, we have to use the pin cell 1 in the initialization. Let us see how we are doing the initialization. Where is the initialization? Yeah. See out, we are programming the pin cell 1 register, not the 0 register, because our port number is 25 and which is beyond port 16 ports, therefore we have to select pin cell 1. This is the analysis that you had to do. And A out is actually 0x20 hexadecimal 2, right? Just see that value. Hexadecimal value, where is that? A out 2. So that is something that you have to remember. And then you had to, there is only one register on the device you need to worry about it. It has data, it's a DAC control register where there is a place for data between the bits 6 and 60. So this is a data register starting from the bit position 6. You have to put a 10-bit data there. And of course, we have a macro. Given the data value, it will shift the data by 6 bits and place it there. So let us see the macro there. So the data is passed here, which is shifted by 6 bits. And there is a mask we are adding, making sure that other 32 bits, other than these 10 bits, are all set to zeros. So that is the mask ANDing with except those 10 bits, rest of the bits in the register should be turned into 0. Looks like we are not using the BIOS because we are not initializing anywhere. Are we not initializing? So we leave it to the default value of BIOS because we are not initializing anywhere. So we can remove that BIOS. So that's all about the DAC program. And then of course you compile, set the target options, generate the X file, using the Flash Magic, download it to the microcontroller and test it out. And you had to remember, of course, on the CRO, the voltage levels and the time axis, because there is only 3 volts signal that you get. So if you choose very high granularity, the wave may not be visible at all. Okay then, bye.